Hey guys, today we are looking at two more special kinds of quadrilaterals called trapezoids and kites. So we'll start off with a trapezoid, and there's a picture there for you. A trapezoid is a quadrilateral, so it's not a parallelogram. It's a quadrilateral with special properties. So quadrilateral with exactly one pair of parallel sides. Exactly one pair of parallel sides. So those parallel sides are called bases. So there's a base and there's a base. So a quadrilateral has two bases. The other sides are called legs. And then these two angles are a pair of base angles, as are these two angles. They're a pair of base angles. So if we want to show that CDEF is a trapezoid, we need to show that one pair of sides is parallel, but that the other pair of sides is not parallel. So the ones that look parallel to me are DE and CF. So I'm going to test those first. And remember that when we're doing parallel, we are doing the slopes. We're comparing the slopes. So we need the slope of DE. So we subtract the y values. So 4 minus 3. And we subtract the x values in the same order. So 4 minus 1. So 4 minus 3 is 1. 4 minus 1 is 3. We get 1 over 3. The slope of CF then is 2 minus 0 and then 6 minus 0. So we get 2 over 6, which is 1 over 3. So then DE is parallel to CF. And then let's look. It looks like from the picture that they're not parallel, but let's show mathematically that they're not. The slope of CD. So the y values are 3 minus 0, and the x values are 1 minus 0. So 3 over 1 is 3. So anything except for 3 would show that EF is not parallel. So 4 minus 2 over 4 minus 6. So 4 minus 2 is 2. 4 minus 6 is negative 2. 2 over negative 2 is a negative 1. So those are not parallel. So we can say then that since exactly one pair of sides is parallel, CDEF is a trapezoid. Okay, a special kind of trapezoid is an isosceles trapezoid. So an isosceles trapezoid is a trapezoid with congruent legs. Just like an isosceles triangle is a triangle that has two congruent legs, an isosceles trapezoid is a trapezoid with congruent legs. We know a few things if we have an isosceles trapezoid. If a trapezoid is isosceles, each pair of base angles is congruent to each other. That doesn't mean all four angles are congruent, but we know that angle A would be congruent to angle D, and that angle B would be congruent to angle C. We also know then that if a trapezoid has a pair of congruent base angles, we can conclude that it's an isosceles trapezoid. So we know that either of those pairs of base angles are congruent, we have an isosceles trapezoid. We also know that an isosceles or a trapezoid is isosceles if and only if its diagonals are congruent. So we know that AC would have to be congruent to BD in an isosceles trapezoid. So here's an example. In a kitchen, a shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. Find the measure of angle in, the measure of angle L, and the measure of angle M. Okay, so one thing we know is that the base angles are congruent to each other. So we know that if angle K is 50, then angle N also has to be 50 degrees. So the measure of angle N is 50 degrees. Now what I want you to notice is if I'm looking at angles L and K, I have two parallel lines cut by a transversal. If this is 50, notice I have consecutive interior angles. So I know that the measure of angle L would be supplementary, or I need to take away from 180. So that would be 130 degrees. And the measure of angle M would also have to be 130 degrees because the base angles have to be congruent. Also, you can check that all four angles add up to 360 because that's true for a quadrilateral, and this is a special kind of quadrilateral. So lots of different ways to check yourself on that one. All right, the mid-segment of a trapezoid is a segment that connects the midpoints of its legs. A segment that connects the midpoint of its legs. Segment that connects the midpoint of its legs. The midsegment theorem for trapezoids says that the midsegment of a trapezoid is parallel to each base and its length is 1/2 the sum of the lengths of the bases. So let's write out what that means. So the midsegment length, so the length of MN is equal to 1/2 the sum of the bases. So we're adding the two bases together. So we have the length of AB and the length of CD. Instead of multiplying by 1/2, I tend to like to divide by 2. So a lot of times I will write it like this instead. Either one of those is fine, but know that you'll probably see the divide by 2 more often from me. Okay, example 3. In the diagram, MN is the midsegment of the trapezoid PQRS. Find MN. So MN equals the two bases added together divided by 2. Oh, this should be MN equals. So 16 plus 9 gives me 25. So I get 25 divided by 2. So I get 12.5. My label there is inches. So the length of that midsegment MN is 12.5 inches. All right, we've talked a lot about trapezoids, but we had another figure here that we were looking at. So a kite. A kite is a quadrilateral with some special properties. So it's a quadrilateral that has two pairs of consecutive congruent sides. quadrilateral that has two pairs of consecutive congruent sides. So notice BC and AB, those are congruent to each other, and then CD and AD are congruent to each other. Consecutive means right next to each other. Alright, so if a quadrilateral is a kite, one special case that we know is that its diagonals are perpendicular. That's always true for a kite. So if quadrilateral ABCD is a kite, then we know that AC is perpendicular to BD. We also know that if quadrilateral is a kite, then exactly one pair of opposite angles are congruent. I'm going to move this up out of the way so we can see this. So we know that if BC is congruent to BA, then angle A is congruent to angle C, but angle B is not congruent to angle D. So the way we know to look at this is that the angle between the different sides, so I have one tick mark here, two tick marks here, is going to be congruent, not the angle between the same side congruencies. Alright, find the measure of angle T in the kite shown at the right. Well, I know, based on that theorem we just talked about, that these two angles have to be congruent to each other. So if I call one x, then the other one would also be x. So I have 70 plus 88 plus x, all four angles of a quadrilateral add up to 360. From there I can solve. So 70 plus 88 is going to give me 158. Plus 1x plus 1x is 2x equals 360. I'm going to subtract 158 from both sides. So 2x is equal to 202. I'm going to divide by 2 on both sides. So x is equal to 101, but it wants the measure of angle T. In this case, the measure of angle T is just x, so it's 101 degrees. Alright guys, that's all we have for today. So if you have questions, please come see me. I will see you in class.